Hello there. Let us continue solving questions on iteration statements. So far, we have solved questions from all of these categories and subcategories, and we got started with the symmetry subcategory. From the symmetry subcategory, we have solved these questions. And in this video, we're going to solve the next three questions, which are these. So let's get started with the first question for this video. So for n equal to 5, this is what we are supposed to print. Now, what is the next step? Well, drawing a grid around this. So let me quickly do that and then continue the discussion. So this is how this pattern would look like with grid drawn around it and the rows and the columns numbered. Now, this pattern is in the symmetry subcategory. And this is not the first question that we are solving from the symmetry subcategory. What I mean is, we've already solved these four questions where we use the fact that the patterns are symmetrical to our advantage. If you have not watched the previous video yet, please give it a watch and that will make the concept clear to you. In this video as well, while solving these three questions, I will ensure that I explain how are we going to use this symmetrical pattern to our advantage. So continuing, if you observe this pattern, you would notice that this pattern is symmetrical across this line, right? So if we take this line into consideration, we have divided this pattern in two parts. This being one of the parts and this being the other. Now, if you check these two, if you compare these two parts, you would see that this part is the mirror image of this, or if we say it the other way, this part is the mirror image of this part, which means that if we figure out how to print this part, we will be able to figure out how to print this part, or again, the other way, if we are able to figure out how to print this, we would be able to figure out how to print this part. So naturally, we're going to figure out how to print this part because this is what we'll be printing first, right? Once we print this, it will be only a matter of time for us to figure out how to print this part also. So let's get started with this part. So let's number this and let's say this is the first part. Now, which is the second part? Is it this? Not really, because as you can see, this line, which is dividing the pattern in two parts, two symmetrical parts, is passing through a row, which is also the part of the pattern. So we will have to take care of this part as well. So let us number this as the second part. And let's say that this is the third part. So in short, what will we have to do is we'll have to figure out how to print the first part. And with this, we will be able to figure out how to print the third part. Now, we have these two done, right? Then we will also have to figure out how to print the second part. So we'll go this way, first part, second part, and using the first part, we'll print the pattern in the third part. So let's get started with the first part. And for that, let me copy that part separately so that we can discuss. All right, so pay attention to this part. Now let's observe what is happening over here in each of the rows. There are four rows. We'll get to that in some time, but let's first observe what's happening in each of the rows. So in the first row, which is this, where the value of I would be 0, what's happening is we're leaving some spaces first, right? So let's note that down also. Let's say S, which stands for spaces, and we're leaving 4 spaces. Then what's happening is there's an asterisk over here, right? So we have one asterisk, and then there are a few spaces. So printing these spaces or not printing should be fine. It will be something like this if we print those spaces. We'll have 4 spaces first, then an asterisk, then we will have 4 more spaces. And if we don't print those spaces, even then it is going to look like this only, right? So we will have an asterisk, and before that, we will have 4 spaces. So what I'm saying in short is we can just take care of these 4 spaces and then print an asterisk, and we will be done with the first row. Coming to the second row, where the value of I is 1, we have got a few spaces here as well. We have got 3 spaces. And then we've got an asterisk. So one asterisk, and then in this case, we've got another space and then an asterisk. So this is one space that we'll have to consider. Why? Because after this space, we're printing an asterisk, and that is why we're not going to skip that space. So let's say S over here again, and we'll put 1 over here, and then there's another asterisk where we will put 1. And if we come back to the first row, what happened in this case is there were, say, 0 spaces, because we are not going to consider those spaces like we discussed, right? And the number of asterisk as well will be 0 over here. Now coming to third row, where the value of I is 2. So we have got a few spaces over here. So we have got 2 spaces. Then we have got 1 asterisk, 3 spaces, and then another asterisk. So 1 asterisk, 3 spaces, and 1 asterisk. Then let's come to the last row, which is this, where the value of I is 3. What's happening over here is we have got 1 space, then 1 asterisk. So let's put that information down. 1 space, 1 asterisk. Then we have got 1, 2, 3, 4, 5 spaces. So 5 spaces, and then we have got 1 asterisk, right? In all of these rows, what are we doing is we're not considering these spaces at all, because printing them or not printing them should be absolutely fine, right? But we are considering the spaces that we have between the asterisks, because these spaces are separating those asterisks, which will be required if we want the pattern to look this way. So now that we have this with us, and also the fact that the value of n is equal to 5, which we know we will need to use, let's now focus our attention to how we can get all of this. We will have this, right? What are we going to do is, because n is equal to 5, what we can do is we can iterate from 0 all the way up to 3, right? So when we iterate from 0 all the way up to 3, we will have 0, 1, 2, and 3 with us. Now, what will we have to do is, when I is equal to 0, we'll have to somehow figure out this number and leave those many number of spaces, then figure out this number, print that many number of asterisk, and figure out this number, leave those many number of spaces, and then lastly, figure out this number, and then print those many number of asterisk, right? So if n is equal to 5, we know that we have to go from 0 all the way up to 3. So what we should be doing is, we should be having a loop, something like this. We should be saying for I equal to 0, I less than n minus 2, is it? Or it should be n minus 1, because n is equal to 5, so n minus 1 is 4. I less than 4 means we're going from 0 all the way up to 3, right? So I less than n minus 1 and I plus plus. So this is something that we will need, but for now, let's keep it separately. What am I going to do is, I am going to copy this part over to another page, and then when we get to the pseudocode, we will complete this part. All right, so with that figured out, now let us focus our attention to this first. That is the number of spaces that we will leave before we print the first asterisk of that particular row. So for that, let's focus our attention to the value of I, which is going from 0 to 3, and the number of spaces that we are leaving, which is going from 4 all the way up to 1, right? Now, if you compare these two, what would you notice is, when you add them up, what are you getting is 4, right? So can we say that I plus space, or let's put it as S1, which is space 1, A1, which is asterisk 1, and space 2 and asterisk 2, right? Because as you can see, we are going to figure out the number of spaces for the later part of the pattern also, and we will have to figure out the number of asterisk for the later part of the pattern as well. So I plus space 1 is equal to 4, right? Because 0 plus 4 is 4, 1 plus 3 is 4, and so on. Now, since I plus space 1 is equal to 4, S1 will be 4 minus I, right? Now, where is this 4 coming from? Because this 4 is not a random number. It cannot be a random number, and it cannot be a constant as well. Every time the value of n changes, this will change. If you understand why, great. If you don't, I would recommend that you print this pattern, actually draw this pattern on a paper, for n is equal to 6 or even n is equal to 4, and you would understand what I mean. So continuing, this 4 is coming from the fact that n is equal to 5. So can we represent this 4 as n minus 1? Well, we can. So S1 will be equal to n minus 1 minus I. So that means that to get the number of spaces that you'll have to leave before printing the first asterisk of the pattern, this is the expression that you can use. So let me put that down over here. S1 is n minus 1 minus I. Now, what is the next part? Well, the next part is asterisk. And as you can see, irrespective of the the value of I, we are going to print only one asterisk. So A1 will be a constant number, which is 1. Then let's move on to S2. And here things change a bit. For I, we're printing 0 number of spaces. Sorry, for I0, we're printing 0 number of spaces. For I1, 1, 2, 3, and 3, 5. So let me note this down separately first and then continue the discussion. So over here, if you take a look, what you would notice is I is going from 0 to 3 and S2 is going from 0 to 5. I is going in increment of 1 and S2 is going in increment of 1 first and then it is incrementing by 2. So in a way, if we take this part into consideration, these are odd numbers. These are consecutive odd numbers, right? So can we write this down as in terms of an even number? So can we say 2 minus 1 over here and 4 minus 1 over here and 6 minus 1 over here? We can, right? So what will be the next step? Well, what are we going to do here is we're going to say 2 minus 1, then 4 minus 1, and then 6 minus 1. Now, in all of these three, we are subtracting 1. And what are we subtracting 1 from? 2 when I is 1, 4 when I is 2, and 6 when I is 3. And you see a clear pattern, right? For these, it is 2 multiplied by I minus 1. See, when I is 1, it is 2 minus 1, which is 1. Then when I is 2, it is 4 minus 1, which is 3. When I is 3, it is 6 minus 1, which is 5, right? So this 2i minus 1 holds for these three. Now, what about this where the value of I is 0 and the number of spaces that we need is 0? Well, there are a few ways to handle it. Let's take a look at them. So we can handle this conditionally. That is, we will use this expression if and only if the value of I is greater than 0, right? We can do that. So one way to handle this is I greater than 0. The other way to handle this would be to calculate this value irrespective of the value of I, right? So if we calculate this value irrespective of the value of I, what are we going to get here? Here, because I is 0, this will become 0. And 0 minus 1 will give us minus 1. So this would be minus 1. Now, what we can do is we're going to use this value if and only if this value is a positive number. We can put that check. And if we do that, we will be using that value for these three cases, but we won't be using the value for this case because this gives us a negative number. So this is another way of solving this, right? So we can say that we're going to use this number if and only if 2i minus 1 is greater than 0. Either way, we'll be able to handle this. This is not a problem, right? So let's note all of this down separately and let's note it here. So for S2, we're going to use 2i minus 1, but there's a condition. There are two conditions and you can use either of them, right? The conditions are I has to be 0, or what you can do is you can use 2i minus 1 is greater than 0, right? Because it is perfectly understandable that if I is greater than 0, this is going to be greater than 0. So either use this or this. And this is how we'll be able to solve for the relation between I and S2. So let me clear this up. And then let's move to A2. And here in A2, what would you observe is for I0, A2 is 0. But for all the other values, A2 is 1. So this also is pretty easy to handle. What we can do is for A2, we can say 1, but the condition is that I has to be greater than 0, right? If I is not greater than 0, it won't be 1, it will be 0, right? So with all of these in place, can we write the pseudocode? Well, yes, we can. And to make it easier, what am I going to do is I am going to copy this and I'm going to paste it here where we are going to write the pseudocode. So let's keep this in one corner of the page and let's get started. So like we have discussed, this is what the for loop, the main for loop or the outer for loop would look like. We will have for I equal to 0, I less than n minus 1, I plus plus. And what are we going to do next is we're going to calculate the number of spaces that we would need, right? That is S1. So let's call it as S1 here also. That is the variable name is S1. And the expression would be n minus 1 minus I. Now, once you have this value, what would that give you is the number of spaces you have to leave before printing the asterisk. And if you have 4, can you print 4 spaces? Yes, we can. We can iterate 4 times and print a space every single time, right? So we can either go from 0 all the way up to 3, which is less than 4, or we can go from 1 all the way up to 4, which is equal to 4, right? And to keep it consistent with the outer loop, what are we going to do is we're going to start from 0. So we'll say for j is equal to 0, j is less than s1, j plus plus, and we will print a space, right? Then once we are done with the space in any given row, we have to print an asterisk, right? And as we can see over here, the number of asterisks that we have to print is 1. So no loop required. All we will have to do is this system.out.print and asterisk, right? Then we'll have to print some spaces again, but then that is conditional. That is, we will need to leave some spaces if the value of I is greater than 0. But if the value of I is equal to 0, we don't have to leave any spaces, right? We've discussed that. So what are we going to do is we're going to calculate S2. So let's say S2 is 2 multiplied by I minus 1. Now, once this S2 is calculated, we'll have to use this loop to print these many number of spaces, right? So let me copy this loop from here and bring it down over here. And what am I going to do is replace this with S2. Now, let's check if this loop, which is almost the same as this, with just the name, the variable name changed, will be able to cater to this need of R. So what are we supposed to do is we're supposed to print spaces if and only if the value of I is greater than 0, right? Now over here, when we calculate S2, what is it going to give us for I equal to 0? For I equal to 0, this is going to give us minus 1, right? Now this loop is starting from 0 and going all the way up to S2, which is minus 1. So it is starting from 0 and that too with an increment of 1. So from 0, it should go to 1 and then 2 and then 3 and so on, right? Whereas S2 is minus 1. So what's going to happen is j will get initialized to 0 and then we will check j less than S2. Now is j less than S2? No. Since j is not less than S2, this condition will not be true. And because this condition is not true, the body of the loop will not get executed, right? So without any special handling, we have taken care of the fact that this loop should run if and only if the value of I is greater than 0, right? So because this loop is self-sufficient in handling that condition, we're not going to put these conditions, that is I greater than 0 or 2I minus 1 greater than 0, right? So we'll leave this loop as it is. And what are we going to do inside this is we're going to print. Print what? A space. Now, once S2 has been printed, what do we have to do next? We have to print another asterisk. But again, there's a condition, which is A2 is 0 if I is 0. Otherwise, A2 is 1. So we'll have to say if I is greater than 0, only then print and asterisk. Otherwise, don't, right? And lastly, we'll put a system.out.println, because what we want is that after the first row is printed, for example, the cursor moves to the second line, and from there, the logic of the second line starts printing these things. And then once this is done, move to the third line, and that is where these get printed, and so on. So this is the pseudocode that will help us in printing this part of the pattern. So with this understood, let's go to IntelliJ and let's write the code for the first part. So here we have src, then we have iteration statements and questions, nested loop patterns, symmetry, and Q4 is done. So we'll go for a class named Q5. We'll have the main method here. We'll take the value of n equal to 5 and we will get started with the first part of the pattern. Now over here, like we have discussed already, we'll need a loop which will start from 0, go all the way up to n minus 1, actually less than n minus 1, so up to n minus 2 with an increment of 1, right? And over here, you have to take care of number of spaces first. So int s1, or let's call it as space count 1 over here, was going to be n minus 1 minus I. And once that is determined, we can continue and we can say int j is equal to 0, j is less than space count 1, j plus plus, and here we can say system.out.print a space. Then once this is done, we would need to print an asterisk. So we will say system.out.print an asterisk. So we'll print an asterisk, and once this part is done, we'll move on to spaces again. So let me copy this and paste it here, and let's change the variable name to space count 2 and the calculation to 2 multiplied by I minus 1. And what are we going to do next is replace this space count 1 with space count 2, and we're done with this. Then what are we going to do is we are going to print an asterisk, and we'll have to put the condition which says if I greater than 0, only then print an asterisk. And once all of these are done, we'll have to move the cursor to the next line. So with this done, if I run the code, what do we expect? Well, this is what we expected, right? This matches the first part of this pattern, correct? So with that done, let's move on to the second part of the pattern. And the second part of the pattern is this, where what we have to do is we have to print an asterisk, leave some spaces here, and then print another asterisk. So let's look for a solution here itself. So here, as you can see, how many spaces are we leaving is 1, 2, 3, 4, 5, 6, and 7, right? Now, I will say that these 7 spaces are related to the value of n. And that is obvious. If the value of n changes, the pattern changes and the number of spaces overall changes, right? So let's try to relate this 7 with n equal to 5. So let's do that part here. And the rest of the part is pretty simple, right? We start off by printing just an asterisk. Then we write some logic to print these many spaces. And then at the end, we print another asterisk. So what we need is 7. And what are we starting off with is 5. Now, for a moment, let's consider that the value of n was 6, which means this pattern would have expanded slightly, right? Or if the value of n was 4, this pattern would have contracted slightly. So instead of this 7, we would have 9 spaces, correct? So instead of 7, we would have 9 spaces for the value of n equal to 6. And again, I'm not going into the details of how am I getting these numbers, but I recommend that you draw this pattern on a paper with a pen for different values of n to get an idea of these numbers. All right, so continuing, I said when n is 5, the number of spaces that we are leaving is 7. When n is 6, the number of spaces we are leaving is 9. Similarly, when n is 7, number of spaces would become 11 and so on. Now here as well, you can see that the value of n is increasing by 1, right? From 5, it is going to 6, and then from 6 to 7. whereas the number of spaces is increasing by 2. So from 7 to 9 and 9 to 11. Now over here, let's change this 7, 9, and 11 as, say, 8, 10, and 12. If we do that, what will we be writing 8 as? 8 will be written as 2 multiplied by 4. Then 10 will be written as 2 multiplied by 5. And 12 will be written as 2 multiplied by 6. Now, if we write 8 this way, what will 7 be written as? So, 7 will be written as this, right? 2 multiplied by 4 minus 1. Similarly, 9 will be written as 2 multiplied by 5 minus 1. And 11 will be written as 2 multiplied by 6 minus 1. Now, if you check this, almost everything is the same. That is, we're multiplying 2 with something, and at the end, we're subtracting minus 1. But that something is changing, right? So, what's happening is, see, when n is 5, this is 4. Then, when n is 6, this is 5. Then, when n is 7, this is 6. So, can we say that it is 2 multiplied by n minus 1 minus 1? It is, right? See, 2 at the start is there in all of these. Then minus 1 at the end, that is at the end of multiplication, is there in all of these, right? What are we multiplying with can be very easily related to the value of n. When n is 5, this is 4. So 5 minus 1. N is 6, this is 5. So 6 minus 1. 7, 6. So 7 minus 1. That is why I'm saying it is 2 into n minus 1 minus 1, right? So what will we have to do in order to handle the second part is we will print an asterisk, then we will calculate this and leave those many number of spaces, and then we will print an asterisk again. So with this discussion done and understood, let's go to IntelliJ and let's write the code for the middle part. Let's call it middle part, not the second part. So middle part would have an asterisk first. So we'll say system.out.print an asterisk. Then we will calculate the number of spaces. So we will say int space count, let's say. So space count is going to be 2 multiplied with n minus 1 minus 1. And we will iterate these many number of times. So j is equal to 0, j less than space count, j plus plus. And it will be system.out.print. And at the end, we will print another asterisk, right? And after this is done, we'll have to leave. Actually, we have to move the cursor to the next line. So we'll say system.out.println. So with this done, if I run the code, this is what we get, which is exactly what we wanted, right? So we are done with the top and the middle part, right? Now, before we continue, this two can be merged. If we print first and then move the cursor to the next line, what's going to happen is the cursor would come over, sorry, the asterisk would come over here and the cursor would be here. Now, if we merge these two, that is, if we say system.out.println and then an asterisk and remove this, what's going to happen? First of all, an asterisk will be printed because we are printing. And then because this is println, which moves the cursor to the next line, the cursor will be here. So both of these are going to give us the same end result, right? So let's remove this and let's be done with this. So we're done with the middle part. Now comes the last part. So let's discuss that first before we implement this in the code. So to discuss the last part, let me copy this part of the pattern and let's paste it over here. So let's compare this with this, right? So what's happening in the first row over here is we're leaving one space, then printing one asterisk, then we're leaving 1, 2, 3, 4, 5 spaces, then printing one asterisk, and this one space at the end, which is something we don't have to consider, right? Now, if we compare this row from any row in this part of the pattern, which row would it resemble with? Well, it is resembling exactly with the last row, right? See, in the last row, we're leaving one space, then printing one asterisk, then we have 1, 2, 3, 4, 5 spaces, and then one asterisk, and then at the end, we have a space, right? Similarly, row 1 over here resembles with the second last row of this pattern, right? As you can see, we have got two spaces, then an asterisk. So two spaces asterisk, then three spaces asterisk, then three spaces asterisk, right? So we can map this with this. Similarly, 2 here would map to 1 over here, and 3 over here would map to 0 over here. Sorry for this mess, but this is just to explain how this and this is related, right? So now we already know how to print this pattern, right? We know to print it from 0 all the way up to 3. And if you compare row 3 of this pattern, actually row 4, where the value of I is 3 of this pattern, with the first row where the value of I is 0 of this pattern, they are the same. So instead of printing from 0 to 3, if we print from 3 to 0, will we be able to print this pattern? Well, we will be, right? If I have the value of I as 3, our calculation would give us 1 for space 1, which is what we need. Then 1 asterisk, which is something we need. Then 5 spaces again, which is something we need. And lastly, 1 asterisk, right? Similarly, from 3, when the value of I goes to 2, our calculation would give us 2 spaces, 1 asterisk, 3 spaces, 1 asterisk. So 2 spaces, 1 asterisk, 3 spaces, 1 asterisk. And the same way for rest of the rows. Sorry, these, right? So if we just invert the loop, we would be able to get this pattern from the code that we wrote for this pattern. And that is why I said we're going to use the fact that the pattern is symmetrical to our advantage. So with that, let's come back to IntelliJ and let me copy all of this first of all. Copy the entire loop, which ends here in line number 30. And let me paste it here. Now over here, what have we discussed on doing was, instead of starting from 0 and going all the way up to 3, actually this is going, this is going till 3. What are we going to do is we're going to start from 3, right? Now this is less than n minus 1, which means it is going till n minus 2. And we have to start from there for the last part. So we'll say for I is equal to n minus 2, I greater than equal to 0, I minus minus. This is all that we will have to do in order to get the last part of the pattern. And if I run the code now, well, this is what we have, which is exactly what we had expected. So we're done with this pattern, right? So with this, let's move on to the next part of the pattern, and we will go a bit faster over here. All right, so for n is equal to 5, this is what we're supposed to print. Now this pattern as well is symmetrical, right? And it is symmetrical across this line. Now this time, the line that is dividing this pattern into symmetrical parts is not passing through any row that is part of the pattern, right? So this divides the pattern in two parts only, correct? Now, if we take care of the first part, we will be able to take care of the second part. That is something we know already. So let's focus our attention on the first part and let's figure out a solution for the first part of the pattern. All right, so over here, what are we doing? What are we doing in the first part? So in the first part, when I is equal to 0, we're printing a few asterisks. And how many asterisks are we printing in total? We're printing 10 asterisks, correct? So number of asterisks that we are printing is 10. Then when I is 1, we're printing a few asterisks. So when I is 1, we're printing 4 asterisks. Then we are leaving some space. So we are leaving 2 spaces. And then what are we doing is we're printing a few more asterisks, right? And how many asterisks are we printing after this? We're printing 4 asterisks. See? 4 asterisk, 2 space, 4 asterisk. Now this looks slightly different from the case when I was 0. So let's make this case similar to this one so that it's easy to find a pattern, right? Now if we do it the same way, see, this is 4 and this is 4, which means this and this could have the same number. And since this is 10 in total, can we say that this is 5 This is 5, and the number of spaces we are leaving in the middle is 0, right? So continuing, when I is 2, 3 spaces, 3 asterisk, 4 spaces, 3 more asterisk. So I is 2, 3 asterisk, 4 spaces, 3 more asterisk. Then when I is 3, 2 asterisk, we have got 1, 2, 3, 4, 5, 6. So 6 number of spaces and 2 asterisk. And 4 will have 1 asterisk and 1 asterisk at the end, and number of spaces being 8, right? We have 1, 2, 3, 4, 5, 6, 7, 8. Correct. So we'll have I, which will go from 0 to 4. Considering n is equal to 5, it will go from 0 all the way up to n, that is less than n. Correct. So let's compare and find the relation between I and A. And for this, what would you observe is the value of A for the corresponding value of I is same here and here also. So when I is 0, A is 5 in both of the cases. When I is 1, it is 4. I2, it is 3. I3, it is 2. And I4, it is 1. So if we are able to find a relation between these, you would have a relation for these as well, correct? So let's get to work and let's put the values down over here. So this is 5, 4, 3, 2, 1. And the relation between these is pretty simple. If you add them up, you would get 5, which means we can say that I plus A is equal to 5. This 5 is not a random number, it is n. So that means A is equal to n minus I. So let's jot that down over here. A will be n minus I. Now we're done with the relation between I and A. Then let's focus our attention to I and S. And for that, let me jot the numbers down here. So it is 0 for 0, 2 for 1, 4 for 2, 6 for 3, and 8 for 4. So number of spaces is 2 multiplied by I, right? So we can say spaces would be 2 times I. Now with these numbers, we will be able to print this pattern very easily, right? And if we are able to print this pattern, it's just a matter of inverting the loop to get this part of the pattern, which will give us this pattern as a whole, right? So with these discussed, let's go to IntelliJ and let's start writing the code. So let me close this. Let's go for new Java class. Let's say Q6. Let's have a main method and a variable n initialized to 5. And then we will have the first part of the pattern where we'll say for int I is equal to 0, I is less than n, I plus plus. Then what do we need first is we need asterisk. And for that, let's calculate. So we'll say asterisk count is going to be equal to n minus I. And here we'll say for int j is equal to 0, j less than asterisk count, j plus plus. We'll then say system.out.print an asterisk. And once this is done, we would then leave some spaces. So we'll calculate the number of space to be left first. It will be 2 multiplied by I. And then what are we going to do is, let's copy this part, paste it here, replace asterisk count with space count, and replace this asterisk which is getting printed with a space. With this done, we would then need to print asterisk again. So let's copy this part, paste over here. Now, because we already have asterisk count calculated, and because we want the same value for the second loop that prints the asterisk, let's get rid of this statement. Now with these done, if I run the code, what do we get? Well, we got all of them in one single line, which is not something we wanted, right? What we wanted was for them to be in separate lines. So we'll put system.out.println and let's run the code. And we have what we expected. So now for the second part, let's copy the loop of the first part. Let's put a comment saying second part. Let's paste the loop and let's start from n minus 1, go all the way up to 0 with decrement of 1. with this code, if I run this, we get this pattern printed, which is exactly what we wanted, right? Now with this done, let's move on to the next question that we had intended to solve today. All right, so for n equal to 5, this is what we're supposed to print, and you know the drill already. So let's get started. The line which would divide this pattern into symmetrical parts is this, which is crossing through one of the rows, which is part of the pattern. So we'll have three parts, right? Let's focus our attention on the first part. That would give us the solution of the third part as well. And then we will figure out how to print the second part, right? So let me quickly copy this, as in copy the first part, and then continue the discussion. So in the first row, what's happening? That is when I is 0, we have got 1 asterisk, and then we are leaving a few spaces, 1, 2, 3, 4, 5, 6, 7 spaces. So spaces are 7, and then we have got 1 asterisk again. Then when I is 1, 2 asterisk, and then 5 spaces, right? 1, 2, 3, 4, 5, and 2 asterisk. When I is 2, 3 asterisk, 3 spaces, and 3 asterisk. When I is 3, 4 asterisk, 1 space, 4 asterisk. So A1 and A2 contain the same number for the corresponding value of I. So figuring out A1 would give us A2 as well. So for figuring out A1, this is what we would need, right? So let's focus our attention to A1 and relate it to the value of I. Now the relation is pretty clear. A1 is just I plus 1, right? So I is 0, A1 is 1, 0 plus 1. I is 1, A1 is 2. Again, 1 plus 1, 2, 3, and 3, 4. So asterisk would be simply I plus 1. Then let's talk about I and S. And what's happening here is I is increasing from 0 to 3 in an increment of 1, and S is going from 7 to 1 in a decrement of 2, right? So first of all, let's convert this to even, as in let's represent this in form of an even number. So it would be 8 minus 1. This is going to be 6 minus 1. This is going to be 4 minus 1, and this would be 2 minus 1. So this can be written as 2 multiplied by 4 minus 1. Similarly, all right. So if you check this, what would you observe is this 2 multiplied by something. That is, this 2 over here is in all of these cases, right? This minus 1 is also there. What's changing is this number with which 2 is getting multiplied. So it is 4 first, then 3, then 2, and then 1. So what's happening is it is going from 4 to 1 for I, for the value of I 0 to 3. So now what we will have to do is we'll have to find a relation between these. And for that, let me write that down over here. And if you compare, what would you observe is adding these two numbers is giving us 4. So 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, and 3 plus 1 is 4. So can we say that this number is simply 4 minus I? We can. And this 4 is coming from the fact that n is equal to 5. So we'll say n minus 1 minus I, which means the number of spaces that we have can be determined this way. It will be 2 multiplied by a number minus I, and that number is n minus 1 minus I. See, I is 0 and n is 5. So this is going to be 5 minus 1 is 4. 4 minus 0 is 4. And we're saying 2 multiplied by that number. So 2 multiplied by 4 is 8, minus 1 is 7, which is what we need. And if you substitute I and n over here, you will get 3. Multiply that by 2, you'll get 6 minus 1 will give you 5, and so on. So for spaces, we have got 2, multiplied by n minus 1 minus I minus 1. So with these two relation, it is very easy to print this pattern, right? So let's go to IntelliJ and let's start writing the code for this. Let's first of all create a new Java class, call it Q7, public static void main, int n equal to 5, first part, and then we did not discuss this, but what's going to happen is, and for that, let's come back here. The value of n is 5. In the first part, we're going from 0 to 3. So it's known that we're starting from 0 and going all the way up to, which is equal to n minus 2. So we'll say an int I is equal to 0, I less than n minus 1, or we could have said I less than equal to n minus 2. Then I plus plus. And then what we will need first is we will need some asterisk. And what is the relation to calculate the asterisk count? It is simple. It is I plus 1. And we'll say for int j equal to 0, j less than asterisk count, j plus plus. We'll say system.out.print asterisk. And then we need a few spaces. So for spaces, we'll say int space count. And then we will use that relation we talked about, which is 2 multiplied with n minus 1 minus I minus 1. And then let's copy this part, paste it here, replace asterisk count with space count, and this asterisk which is getting printed with space. And then we need to print asterisk again. So let's copy this, paste it here, get rid of this statement because the number of asterisks that we are going to print after spaces is the same as the number of asterisks we printed before spaces. So with this, we're done with the first part of the pattern. So now let's run the code to check if it is working fine, and it won't. Yeah, because this is missing, system.out.println. So if I run the code now, well, it is working fine, right? This is one part of the pattern that we are attempting to print. For the second part, let's come back over here and let's take a look at this. See, we've got a total of 9 asterisks over here because it is going from 0 all the way up to 8, and that is because n is equal to 5. So if the value of n changes, the number of asterisks that we are printing in the case in the second part is going to change, right? So let's note this thing down over here. For n is equal to 5, the number of asterisks that we're printing is 9. If the value of n becomes 6, it is going to be 11. If the value of n becomes 4, it is going to be 7, and so on. So again, I'm not drawing patterns for the value of n is equal to 6 or 4 or any other number, but I recommend that you do so that you get an idea of where these numbers that I am giving out are coming from. Now, the relation between these two is simple. You already know how to determine that, right? So if you see, this is 10 minus 1, this is 12 minus 1, this is 8 minus 1. Now, 10 over here, 12 over here, and 8 over here are double of these numbers, right? So what we would need to do is we would have to go for 2n and then minus 1. This relation would give us the number of asterisks to print in the second part, right? So 2n minus 1 is all that we need. So coming back to IntelliJ, let's write the code for the second part or the middle part. Now over here, we will have asterisk count is equal to, like we discussed, 2n minus 1. And let's copy paste this part of the code. And this should be good to go. Let's run the code. And yes, it is. Now, the only thing we need is to move the cursor to the next line, because if we don't, the next part of the code that we write is going to start printing from the same line. So let me demonstrate that to you just for fun. Now, what are we going to do is copy the code of the first part, put a comment over here saying last part, paste it, and we are going to change this to start from n minus 2 and to go all the way up to 0 and decrement of 1, right? Now, this one error over here, which is asterisk count, and this is happening because we have declared a variable called asterisk count in the scope of the main method. That means this variable is going to exist, or it is going to stay whole throughout the main method. And this loop for the last part is also inside the main method, which has got a variable of the same name. And that is why there's a conflict. So a quick way to resolve this is cutting this expression from here and pasting it here, because this expression was needed only here. I mean, there are other ways to fix this, but this seems to be the quickest way. And there it is gone. Now let me run the code without putting a println after this and see what happens. And as expected, it is a little messed up. So to fix this, let me put println over here and then run the code, and it is fixed and it is giving us exactly what we wanted, right? So with this, we've solved the 3 questions that we intended on solving today. And in total, we have solved 7 questions from symmetry and a lot of questions before we started the symmetry subcategory. So I hope I've been able to teach you something new and useful. And with this, since we have come to the end of the video, if you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.